Let's say you're given this diagram of two balls' trajectories traveling with different initial angles, and the question says, consider a ball being launched with the same initial speed of VO equals 20 meters per second from different angles, theta equals 30 degrees and theta equals 60 degrees. Show that their speed will be the same at any height in motion. Take height equal 5 meters, for example. To start, since there's no force acting on the object other than gravity, we can use the conservation of mechanical energy, which is given by this expression below, where V1 is the initial speed, Y1 is the initial height, V2 is the final speed, and Y2 is the final height. Note, this equation represents the energy of the ball throughout its motion in both cases. In the first case here, E1 is going to be the energy at the bottom, and then E2 is going to be the energy at 5 meters. And this is going to be the same in the second case. So we can solve for V2 in the equation, noting that in both cases, Y1 is equal to 0 meters, that's the initial height. Y2 is equal to 5 meters, that's the final height we chose. And V1 is equal to 20 meters per second. This is the same initial velocity in both cases. Sorry for that error, I put 5 meters per second, my bad. We can solve for V2 in our equation. We can isolate it by first multiplying both sides by 1 over m. So all the m's are going to cancel. And then we can bring the first term on the right side to the left-hand side to isolate for V2. Then we can multiply both sides by 2. It's going to cancel the 1/2 on the V1, but they're going to stay on these two terms here. For these two height terms, there's a common rewrite we can do. We can just take the 2g out since they are in both terms. And we get this expression here. This is the speed at any later time when conservation of mechanical energy is valid. So we can apply this to our situation. Both cases, the initial velocity is 20 meters per second. H1 is going to be equal to 0 meters. H2 is 5 meters. You can plug all these in, and then we can compute the amplitudes and units of the term on the left and the term on the right. Do a simple subtraction, square root both sides, and then we get this for the answer. This is the speed both balls are traveling at a height of 5 meters. So if we draw a diagram here, at this point in our 60-degree case, it's going to be traveling with the speed 17.3 meters per second in this direction. In our second case, at the 30-degree angle, it's going to be traveling with a velocity of 7.3 meters per second in the horizontal direction. So there's two key takeaways. First thing is the speed are the same, but the velocities are not. At 60 degrees, the ball is traveling in a different direction than at 30-degree case. As we can see here, in the 60-degree case, it's traveling in the upper right direction, and then in the 30-degree case, it's traveling directly in the horizontal. This means that their velocities are different, but their speeds are the same. And the second important thing to note is that this is only true if both trajectories reach the height. So if we picked 8 meters, the second ball never reaches 8 meters, so this equation wouldn't hold.